Alrighty, so this one is 5.4, properties of the definite integral, and you'll be happy to know that I actually record my lessons back to back, and I shooed my children out so you don't have to hear this like weird kind of sounding like a ghost screaming in the background, which is my youngest, London, who is 6. So I shooed her off. I scared her away. I don't really know. I told her to go downstairs, so she did. And it should be better. So example 1, determine the definite integral below. So what we did before this in the previous day is we looked at integrals that only had one term. So now we're going to look at ones that have more than one term, or possibly are piecewise functions. Okay? So example 1. Determine the definite integral below. So now we're looking for the area under the graph x squared plus ex from 0 to 1, or the integral from 0 to 1. But indirectly, that's what we're finding every time. Just like when we always found the derivative, we were technically finding the first derivative, but we could have been finding the tangent slope every time. All right? So, still using the fundamental theorem of calculus, we are going to take the antiderivative of x squared plus ex. So we just do them separately and get that. All right. So the antiderivative of x squared raised to the power of 1, so I get x to the 3, and then I divide by 3, which I had a 1 in front, so I'm going to divide by 3, so I get 1/3 x cubed, plus the antiderivative of e to the x, which is e to the x. Not only is it the best derivative, it's also the best antiderivative because it stays the same. And then we went from 0 to 1. Then it's the exact same steps. So we're going to fill a 1 in first. So we're going to get 1/3, 1 to the 3, plus e to the 1, plus c. Oops, I forgot the plus c. Oh my goodness. Plus c, minus 1/3, 0 to the 3, plus e to the 0, plus c. And then 1/3 to the 1, or 1/3 times 1, because 1 cubed is 1, is 1/3. E to the 1 is just e, plus c. And then 1/3 times 0 cubed. 0 cubed is 0, so we're going to get 1/3 times 0, which is minus 0. E to the 0, remember e to the 0 is just 1. So we're going to get minus a positive 1, because remember we have to distribute. So we get plus 1, but it's minus a plus 1, so it's minus 1 minus c. The c's cancel, and I'm left with e, and then 1/3 minus 1 is minus 2/3. And that's my answer. So the answer to this integral is e minus 2/3, technically. Okay, what if I do 1/4 and then 3 over x dx? So I showed you that we could write that 3 in front, and I know 1 over x is just ln, antiderivative. So what we could do is we could go 1 to 4, to put the 3 in front, 3 times 1 over x dx. And if I just have a coefficient, I could bring it in front of the integral. Could you leave it inside and just do it the whole way along? Sure, absolutely you can. I'll show you the 2 ways. So I'll pull the 3 out first, and then I'll show you if I don't. So I take the 3 out, and then I'm left from 1 to 4, 1 over x dx. Okay, the antiderivative of 1 over x is ln x. So I could go 3 bracket ln absolute value of x plus c from 1 to 4. And then a 3 would just sit out front. So 3 ln absolute value of 4 plus c minus bracket ln, I'm in the dead zone on the iPad, ln absolute value of 1 plus c. So I'm going to get 3 ln of 4, because the absolute value of 4 is just 4, plus c minus ln of 1 minus c. These cancel, and I'm left with 3 ln of 4 minus ln of 1. And so I get 3 ln 4 minus 3 ln 1. So I could do it that way, where I took the 3 out, or I could keep the 3 in, and I'll show you. So I could go 1, 4, 3 times 1 over x dx. Oops, did that again. And so then that equals, and just do the antiderivative of that right away. So I would get 3 times ln absolute value of x plus c from 1 to 4. And so I would get 3 ln 4 plus c minus 3 ln absolute value, of 1 plus c. So I would get 3 ln 4 plus c minus 3 ln of 1 minus c. And the c's cancel. And I get the answer I had before, 3 ln of 4 minus 3 ln of 1. So it doesn't matter if you take it out or keep it in, you'll still get the same answer. All right. Oops. So C, it's 4 terms over 1 term, and they all have x's. There's no square roots. So what I would do first is just divide every term by 2x before I would even try and find the integral. So I'm going to get equals 1 to 2, 3x cubed divided by 2x plus negative 6x squared divided by 2x plus negative 5x divided by 2x plus 4 divided by 2x dx. Okay, now I'm going to reduce those. So I'm going to get from 1 to 2, use a different color. X cancels off one of those, so I have x squared. So I'm going to end up with 3 over 2 x squared. The x cancels off one of those. And then negative 6 divided by 2 is negative 3x. The x's completely cancel. Negative 5 over 2. Then take a 2 out. And I'm left with plus 2 over x. Dx. Now I can do the antiderivative of that. So I'm going to get increased by 3, or by 1, so x to the 2 is going to become x to the 3, with the 3 halves in front, and then I'm going to divide by 3 or multiply by a third in front, minus 3x to the, raise it to 1, so 1 to plus 1 is 2, and then divide by 2. Whenever I have a constant, it becomes negative 5 over 2x, because remember, you just get an x on it. And then we're going to get plus 2, and then it would technically be 2 times 1 over x, just like we did 3 over x up here. So 2 times 1 over x is just 2 ln absolute value of x plus c from 1 to 2. These 3's would cancel, and then I can fill it in. So I'm going to get 1 over 2 times 2 cubed minus 3 over 2 times 2 squared minus 5 over 2 times 2 plus 2 ln of 2, ln of the absolute value of 2, which is just 2, plus c, minus, that was a 1 in front, or a 1 in for x, so 1/2, 1 cubed, minus 3/2 times 1 squared, minus 5/2 times 1, plus 2 ln of the absolute value of 1, or just 1, plus c, in brackets. So what I'm going to get is going to be 2 cubed, which is 8, divided by 2, which is 4, minus 4 squared, which is 2 squared, which is 4, times 3, which is negative 12, divided by 2, which is 6. These 2's cancel, so minus 5, plus 2 ln 2, plus c, minus, and now I have to remember to distribute that minus sign through as I do the math. So 1 cubed times 1/2 is 1/2. So I'm going to get minus 1/2. 1 squared times negative 3 over 2 is negative 3 over 2, but I'm going to multiply by negative 1, so I'm going to get positive 3 over 2. Negative 5 over 2 times 1 is negative 5 over 2, but I have to multiply it by negative 1, so I'm going to get positive 5 over 2. Minus 2 ln of 1, minus c. C's cancel. And I'm going to get ln of 1 is just 0, so negative 2 times ln of 1. This just becomes, I'm going to change my pen color. This is just 0, so then it's going to be negative 2 times 0, so that cancels. So I'm going to be left with 2 ln 2. I can't do anything about that. And then I'm going to go 4 minus 6 minus 5 minus 1/2 plus 3/2 plus 5/2, and you get negative 7 over 2. So my answer is 2 ln 2 minus 7 over 2. Okay, so that's going over definite integrals if there are more than one, if there is more than one term. Okay, what happens if we have piecewise functions? So here they want us to find the area under the graph. When they say find the area under the graph, we can use integrals. So we want to find the area under the graph from x squared from 0 to 10, and f of x equals 100 from 10 to 15. So, and then they want us to find the area from 0 to 15. So we are going to have to do the integral from 0 to 10 of x squared dx and add it to the area from 10 to 15 under 100 dx. So you just have to find the two integrals and then add them. So we're going to get the antiderivative of x squared, add 1 to it, so I get x cubed, divide by 3, so I get 1/3, plus c from 0 to 10. Plus 100 is just a constant, so when I go to do it, it becomes 100x plus c from 10 to 15. And then we just do them separately, just like we had 2, and then add them up. So I'm going to get 1/3 10 to the 3 plus c minus open bracket 1/3 times 0 to the 3 plus c, another bracket, plus 100 times 15 plus c minus 100 times 10 plus c. So 10 cubed is 1,000, so I'm going to get 1,000 over, this equals 1,000 over 3 plus c Negative 1/3 times 0 is 0, so minus 0 minus c, plus 100 times 15 is 1500, plus c. 100 times 10 is negative 1000, and then I have to minus c. So the negative c, positive c cancel. So we're going to end up with 1000 over 3 plus 500, which is the same as 1000 over 3 plus 1500 over 3 to get common denominators, which is 2500 over 3. So that's the area from 0 to 15 of this piecewise function, where the graph is actually x squared from 0 to 10, and then it follows the line y equals 100 from 10 to 15. Okay, so if it's piecewise function that you're trying to find the area underneath, you still just do it in pieces and add them up. Still fundamental counting principle. All right, so let's look at this one. So find from negative 1 to 4 of f of x dx when f of x is e to the x from negative 1 to 0, 5 at 2, and then x plus 2 from 0 to 4. Okay, now at 2 it's equal to 5. There's no area under it. That would just be a dot. You'd have a coordinate at 2 and 5, a dot. There's no area under that. So actually where it's equal to like this, we're not even going to really be concerned about that to find area, because the graph is actually x plus 2 for the area when we're dealing with the 2. Okay? So we are going to go from negative 1 to 0 is represented by the graph of ex dx. Then we need to take our next piece. Our next piece is from 0 to 2. I know this is from 0 to 4. That doesn't matter. We still have to stop at 2 because there was an equal to 2 in here. So we're going to go from 0 to 2, and that's inclusive of the x plus 2 graph. X plus 2 dx. Plus, now we have to go from 2 to 4, and that's still the x plus 2 graph that covers. So we're going to do them separately so we show that there actually was a 2 coordinate in there. Okay, so we're going to do this. The antiderivative of e to the x is e to the x plus c from negative 1 to 0, plus the antiderivative of x is raised it by power, so it's going to be x squared divided by 2, so or else 1/2 x squared. Constant just gets an x, so plus 2x plus c from 0 to 2. And then we're going to get the same thing again. 1/2 x squared plus 2x plus c from 2 to 4. And we need to show this 0 to 2, 2 to 4, so that we're actually making light of the fact that there is a coordinate at 2, 5. So there is a breakup in the graph. All right, now we do the fundamental counting principle 3 times technically. So we're going to do e to the 0 plus c minus e to the negative 1 plus c plus 1/2 2 to the 2 plus 2 times 2 plus c minus 1/2 0 squared plus 2 times 0 plus c plus, I have to do with the 4 and the 2, 1/2 4 squared plus 2 times 4 plus c minus 1/2 2 squared plus 2 times 2 plus c. Okay, let's look at the math for this. So I use gray. E to the 0 is 1. We learned that way before when we were doing slopes of tangents. So we get 1 plus c. Now e to the negative 1 is just 1 over e. So we're going to go minus 1 over e minus c, because we have to remember to distribute that negative sign, plus 1/2 times 2 squared is 4 divided by 2, which is 2, plus 4 plus c minus 0, because 1/2 times 0 is 0, minus 0 minus c. And then 4 squared 16 divided by 2 is plus 8. Plus 8, 2 times 4, plus c. Then we have to minus the rest. So 2 squared is 4 divided by 2 is minus 2. 2 times 2 is 4, but it's going to be a negative 4 because we have to distribute that minus sign through. Minus c. So, let's pick a brighter color. C, this C cancel, this C, and this C cancel, this C, and this C cancel. If your C's don't cancel, you forgot to distribute your minus sign throughs. So we're going to get negative 1 over e, and then we have to combine everything else. So 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, plus 8 is 23, minus 2 is 21, minus 4 is 17. And there's your area into the curve. The last thing we're going to go over is average value of a function over an interval. So let f be a function that is continuous on the closed interval from a to b. The average value is what? So we need to find the average value of f of x equals x cubed on the closed interval from 1 to 2. If you're ever asked for the average value, you're just going to use this formula. This is still your a, this is still your b, just like it was before, and this is your f of x, and we just fill it in. So average value equals 1 over b, which is 2, minus a, which is 0, from 0 to 2, x cubed dx. So we're going to get 1/2, 0 to 2, x squared dx. And then we just need to multiply 1/2 by the antiderivative, or the integral, from 0 to 2. So we're going to go 1/2. Now, the antiderivative of x squared is 1/3 x cubed plus c from 0 to 2. So we're going to get 1/2 times 1/3 2 cubed plus c minus 1/3 0 cubed plus c. So we get 1/2 times 8 over 3 plus c minus 1/3 times 0 is 0 minus c. So I'm going to get 1/2 times 8/3. 1/2 times, oh, it's dagnabbit, it's to the 4. I went down. Well, isn't that disappointing? Erasing, erasing. I did the derivative. I haven't done this in a long time, where I accidentally took the derivative instead of the antiderivative. So it was about time. So sorry. We have to go up 1. Oh my goodness. I wrote this. Oh, I did it right. I just wrote 1x squared like a silly Billy. Goodness gracious. It's x cubed, and then I copied it down as x squared. Seriously now. Okay. X cubed dx. My goodness. Well, that was a waste of time. Okay, so sorry. So we get 1/2 times 1/4 x to the 4 plus c. Now that's actually correct. So that's good. Whoopsies. So okay, now do that. So we get 1/2 times 1/4 2 to the 4 plus c minus 1/4 0 to the 4 plus c. So we're going to get 1/2. 2 to the 4 is 16. 16 times 1/4 is like 16 divided by 4, which is 4, plus c minus 0 minus c. And so I just get technically a half times 4, which is 2. Sorry, we had to redo that. Didn't mean to do that. I just copied down x cubed to x squared in one line, which is super awesome. All right, that is all for definite integrals of this form. Next week, we're going to look at definite integrals where we have to actually do a substitution method. Have a nice day.